So today's objective is just basically to review slope. Okay. And actually, I think almost every single set of notes from this chapter could have the word review in it, because this is a review of the algebra class, a lot of different portions of it, mainly chapter 6 or 7. I'm trying to think if there was anything from chapter 8. I don't think so. Oh, well, there's a little bit from chapter 11 with the distance formula. Okay, so this comes out of lesson 13.2. So you can go ahead and read that. So who can give me a good definition of what is slope? So let's hear what you guys remember. Josiah. That's telling me how to find slope, but that's not a definition of slope. We have multiple ways of having how to find it. Okay. Isabel?
Steepness of a line
Okay.
on a graph.
Okay, so basically, slope just indicates how steep a line is. And we have like a 90-degree value that we can go, because it's the same this direction, it's just the sign changes, right? So if we're at horizontal, that's a pretty flat line. That's not steep at all. But as we approach the vertical axis, okay, approach y, now we have extraordinarily steep, okay? And we're all in between, okay? So basically, it is a ratio of the change in y, which would be the vertical change, to the change in x, which would be a horizontal change, it deals with the steepness of a line, you hear the word slant, okay? Who can remember what is the symbol for slope? Yeah. And again, they have no, I've looked at different places, and there's really no explanation how they came up with M. There's speculation that it came from French for the word for mountain, because mountains are steep. But they actually have no verification if that's right or not. It's not Greek or Latin. The S has traditionally been the length of a side of a square. So that's why they don't use it for slope, because it has another way to describe it. So that's that. Now, what Josiah mentioned was rise over run. Now, rise over run is a really elementary way of figuring out slope, and here's the reason why. You can only use rise over run if somebody's given you a graph. That's it. If they haven't given you a graph, a picture, then you can't figure out rise over run. So that's how we begin to teach you how to do slope, is through looking at a graph and counting the rise, which is the change, the vertical change, over the run, which is the horizontal change. But what we did is we taught you a formula that was more applicable. What if I tell you these 2 points are on a line? How can you figure out the slope? Who can remember that formula? Because that's the most important formula to know. Aiden. No, that's slope-intercept form of a linear equation. So we're just looking for the equation of how do you calculate slope. Paige. That what we do is we take 2 ordered pairs. Oops, sorry. We subtract their y's. That's that vertical change. And we divide it by the difference in their x coordinates, their horizontal change. So again, where x sub 1, y sub 1, and x sub 2, y sub 2 are points on the line. So a couple things to mention about this is notice that one above the other, the x and y are from the same ordered pair. So we have y sub 2 over x sub 2. They come from the same ordered pair. We have y sub 1 over x sub 1. They come from the same ordered pair. So when I'm always doing my slope, all I do is I take my ordered pair, I shift it left 90 degrees, smacks the y on top of the x, and I put it into the formula. And I do that every time, and it just helps me. And then I put in the fraction bar between the both of them, and I put subtraction. The biggest issue we have, number one, is not paying attention to signs. Number two, if you mix up an x and a y, like you do y sub 2 minus y sub 1 over x sub 1 minus x sub 2, you're going to get the opposite sign to your slope, which actually takes your line from facing one direction to facing the opposite direction. So that is a huge problem in doing slope, okay? All right, so we have 4 types of slopes for you to pay attention to. So I'm going to draw 4 pictures, and then we will label each of them what kind of slope do we have. So you're going to draw 4 coordinate systems, and we're not going to put any numbers in. And let's see how much you guys remember. Okay, first line. Boop. What kind of slope does that line have? Yep, that's a positive slope. So if it's facing up in the first quadrant, so the arrow cap is up in the first quadrant, then you've got a positive slope. And then we've got this. And think about it, with the positive slopes, your x are positive, your y's are positive, or your x's are negative and your y's are negative. So that would give you a positive slope. So this one, what would you get for the second one? That's a negative slope. If you look at your coordinates, in the upper left, your x's are negative, but your y's are positive. So you're going to have opposite signs and get a negative. Or you have positive x's and negative y's. Again, signs are opposite, so you're going to get a negative. Okay. How about this guy? It is a horizontal line, but that doesn't tell me the slope. No, I'm hearing debate. I'm hearing no slope. I'm hearing undefined, and I'm hearing 0. So here's the first thing. Number one thing out of your vocabulary is no slope. And the reason why is that you don't know how to interpret that. I have some people say no slope means there isn't a slope, and some people say that means the slope is 0. You cannot have one phrase that represents 2 different types of answers. Okay? So no slope is not an acceptable answer at all. Slope here, think about it. If I have different points here, so this x is going to be different, but it's going to have the same y value as this guy. When I take y, take away y, over x sub 2 minus x sub 1, what do I have on top? 0 over some number. What's 0 divided up by a number? 0. The slope of all horizontal lines is 0. Because the 0 in the slope formula is in the numerator. Okay? What kind of line? No, what kind of line? And I heard somebody say the words that are outlawed. There is no slope is not an answer. Your book last year did a disservice to you. Okay. This slope is undefined. And why would it be undefined? What happens here is the 2 points have the same x's but different y's. So when I put it into the formula and I have y sub 2 minus y sub 1, I have x minus x, which gives me some number on top and a 0 on the bottom. And this is what makes that slope undefined. Okay? So the larger the slope, and by the way, it doesn't matter, bless you, if it's positive or negative, because you can just look at the absolute value of the slope. So the greater the number of the slope, the steeper it is, the closer it's going to approach your y-axis. Okay? All right, that's all I have for you today.